some more normal distribution questions. The mean cricket score in a 50 over match is 200. So anytime we're doing these questions, we'll do a little sketch. We'll try and have the tail, instead of like mine curling back up, curling down towards the line. Put your average in the middle. In this case, we have 200. We're told standard deviation is 50. And assuming that such scores are normally distributed, which they always are, what percentage of these scores are greater than 300? So we're testing 300 x bar minus mu over sigma. My standard deviation will give me a z-score. So I'm testing 300. You can see it's two standard deviations above 200. Divided by 200 divided by 50 is going to give me 100 over 50, which is 2. So you go to your z-score table to get a score of 2. And 2 is represented by 0.9772. So greater is in here. So this area in here is 1 minus 0.9772, which you can see is 228 or 2.28. I'll just put my nod in. 2.28% if we're asked for percentage in this case, and we are. X is a random variable that is normally distributed. Mean 68, standard deviation 10. The probability of less than 80. Again, I'm just going to do a little sketch. Here's my mean. My mean is 68, just so I can see where my area is. We're looking for less than 80, so we're up here. So if we can, we're not looking for that bit, we're looking for the bit to the left of it. So we're testing 80 against 68. And we're dividing by my standard deviation of 10, which is 12 over 10, or 1.2. And a z-score of 1.2, if you look down your list, 1.2 exactly is going to give 0.8849. So there are 88.49% that are less than 80. Now we're looking at greater than 90. So another little sketch, greater than 90. It's only a small amount, 68 in the middle. So 90 we're in here. So we're looking for a small bit. So we're testing 90 against 68, which is 22 over 10, which is equal to 2.2. And a z-score of 2.2 gives me 9861, 0.9861. So there's 0.0139 or 1.39% in that tiny little bit in there. Then between two values, between 60 and 80. So have we tested either of those? We've tested 80. Okay, we've tested 80. And we're testing 60 now, so I'll do it up beside it. So when we tested 80, we got what was in here. So that's going to be important. So now we're looking between, what did we say, 60 and 80? Between 60 and 80, you can see here they're only sketches. So if this is 60, this is 68, and this is 80, we're looking for the bit in between. So if we get 60, if we get the tail of 60, we have the tail of 80. If we take them away from one, we'll get what's left in the middle. So we test 60. You can do 68 minus 60. We're just looking at the negative part up here, but it doesn't really matter. So we're going to have minus 8 over 10. I'm just going to reverse that around and call it 8 over 10, or 0.8. So a z-score of 0.8 is going to give me, it's equal to 0.7881. So if I get the tail of that, which is 0. What do we have to add? 22, 21, 19 is what I'd have to add. So if I do a slightly bigger sketch, it means that the tail of my 60, which we've reversed around, we got the positive answer up here. We're looking at the negative part, is 21.19%. And when we tested earlier, we tested 80, we actually just got the left hand side of it. So the tail of 80, 0.8849, is slightly less than 12, no, 0, so 11, 51, 11.51%. So that's going to give 32.7 inside this section in here. And what way were we asked for it in a particular format? Just the probability that x is between 60 and 80. The probability is 32.7%. That it's in the tails. So in between 100 minus 32.7 is going to be 67.3% in the middle of that distribution. That's question 1 and 2. Note 2b. If leaving certain maths marks are normally distributed, well, it depends on the class. With a mean of 68 and standard deviation of 10, it's the same type of question. They're giving us 68 with a standard deviation of 10. What percentage will get a mark of 85 or more? So we're testing 85 up here. So a small amount in here. 85 minus 68 over 10, which is 17 over 10, 1.7. And a z-score of 1.7 gives me 0.9554. 0.9554. So the tail 1 minus 0.9554 is going to be 4.46%, which I think is what we were asked for. What percentage? Okay. Number 3. The heights of men in Ireland are normally distributed with a mean of 168, standard deviation 6. Probability that an Irishman selected at random will be greater than 180. Doesn't take long to do a sketch. We have 168 in the middle. We're testing 180. So greater than 180, we're looking for the tail here. 180 minus 168, which is 12, divided by 6 is 2, which we had at the beginning today. 2 gives 0.9772. 0.9772. I'd have to add just less than 3, 0.228. So 2.28% of Irish men are greater than 180 centimeters. Can't be true. We're all tall and lean. The weights of people in Ireland are normally distributed with a mean of 68, standard deviation 10. If an Irish person chosen at random has a weight of X, find the chance that S is less than 61. So they give us the answer here. So we're testing 61, 68, 10, 61. We're testing 61. 68 is my average, and sigma, my standard deviation, is 10. So we're testing 61 against 68. So I can do 61 minus 68 if I want to look at the negative side. But I'm just going to do 68 minus 61 here. So we've got 7 over 10, or 0.7. So I'm testing this value down here, and it's the probability of less than 61. So we're looking for the tail, which what I'm actually doing is testing 7 greater than, and I'm testing this number up here. So I'm really testing 75 minus 68, but it's exactly the same thing. So what's in the tail here? 0.7 as a z-score is 7580, which means that 0. Just less than 25, 2420. So 24, 0.242, 24.2% of people less than 61. Then we're asked between 60 and 61. So we got to test 60. So let's do that. Let's test 60. 60. My average is 68 in the middle. Minus 68. I'm looking at 0.8 here. Between these two values, divided by 10. So if I look up 0.8 as a z-score, I'm going to get... I get 0.7881. So for we're asked kind of for what's between them, we just do a sketch here, which I've always told you to do. Here's my woggity sketch, and I'm testing two numbers down here. Let's just put them here and here. To get what's between them, we'd have to say, well, one tail take away the other tail is going to be what's left between them. So if I get the tail of this, it's going to be 2119, 0.2119. So I'd have to say 0.2422119 is going to give me 242,301. Is that 0.0301 is what I'm getting for that one. And then finally, between 63 and 73, between 63 and 73, okay, we haven't tested either of those, so 68 in the middle again, so we're going 5 above and 5 below here, aren't we? We're 68, we're going to 73. You can see again here, these sketches are just to help, they're not artistic pieces of work like some people are capable of, but I'll make it a little bit more normal. So between 63 and 73, well, if I can just get this part in here, between 68 and 73 after 50, I can just double it. It's probably the easiest way to do this one. So I'm just going to test 73 against 68, which is 5. The standard deviation is 10, 0.5. A z-score of 0.5 gives me 0.6951. So 69.5% is from 73 back all the way to here. So back to 50, I've got 19.5%. And I just changed the color. We're also going to have 19.5% in here. So 19.5 by 2, 38. 39% are going to be between 63 and 73. Here I wrote 5.1, it's 1.5, so just be careful, 69.15%, which is going to be slightly different than that, 19.15, so it's going to be 38.3. Just check your answers at the end.